Okay, so this is my solution for IoT. It's called car alarm system and air quality analysis within the automobile. So first we have three problems. Number one is theft. Number two is liberation of toxic gases derived from petroleum within the cabin. And number two is high temperatures within the automobile. And then our system solutions design is based on the following pub sub model. So we assign basically values or roles to different components of the system. Our main publisher is ESP32 with a broker called ThinkSpeak that's online. And also our main consumer is an app that we developed in React. So we have three sensors: temperature, gas, and distance. And this will send readings of analog signals to converted into electricity to the ESP32, where it processes these signals, sends them as numbers through MQTT to the broker, and then the broker registers them and sends the readings over to our web application, which will eventually be showing it to our user. Another interesting thing is that the web application turns into a publisher as well, because we basically send a Boolean value to the broker, and then the broker, the ESP32 is subscribed to this broker, where depending on if either it's a 1 or a 0, it's that the alarm is on or off. And depending on if the alarm is on or off, we will see if the buzzer should sound, the alarm should sound. If it detects a distance from its origin of opening like more than 5 centimeters, there's a bigger distance than 5 centimeters right here, it's going to go ahead and sound. And also we have an LED display that is just showing us results real time because it's easier for tests that way. And our web application was designed in React with Bootstrap because we just thought it looked good and it's quite simple and rather intuitive. And we will be sending the readings through this web application. We chose React because we thought it would make a simple workflow, as well as we're using an API provided by ThinkSpeak to get the data. So it's just easier for us to mold a front end around this API. Some interesting things is that when the alarm is sounding, it also sends a little red indicator to the user. And the implementation, we have a circuit diagram where we have the LED display, ESP32 chip, our distance sensor, our temperature and gas sensor, all connected to the same 5-volt power source. The buzzer is passive, so there's no need for it to be connected to this power source. And validation of results. So another thing is that the temperature also has humidity. And well, first off, in the first image, we use the sensor in our classroom environment where the temperature and humidity is normal. And then we put it inside a thermos where the temperature and humidity should be higher. And effectively, it did become higher than before. Then our distance sensor, first we measured 4 centimeters and then we measured 6 centimeters. In the second image, the alarm should be sounding because it is greater than a 5 centimeter distance. And then for our gas sensor, which is specifically gases that come from petroleum. So we used methane that is inside a lighter, and we just basically expulsed a bit of it. And then the sensor would pick it up over time. So at first it was 252 parts per million, and then we got 1003. Another thing about our application is that it has different ranges where it would tell you this is bad, this is acceptable, this is good, or this is terrible. And in the case of 1003, well, it's terrible because it is above 600. Anyways, we have also our ThinkSpeak channel validation, where we just have these 4 fields and they are changing over time, which is basically the definition of signal, physical quantity that changes over time or any other independent variable. And then we also finally have our other channel, which is for our car alarm system, where it's either 1 or 0. That's why there's just significant drops and also going ups, right? Rises. So our experimental results, I just wanted to show the buzzer really quickly of how it worked. Which is right here. So we see the buzzer sounding and also the display being the proper one in the app, right? The door opened and the buzzer started sounding. And finally, as a conclusion, this class was rather interesting. I'm a computer science major, but I was able to find different skills from computer science that I was able to apply here, like conditionals in case of the buzzer sounding is an example. Also, we have to take into account a lot of things that are of system design. So one of the particularly challenging parts of designing the prototype was identifying what were the necessities that it needed to comply with, right? And yeah, another thing that's really important to say about this is that it is a prototype. It was designed just for the functionalities. With higher production, um, we would obviously be able to have a system that we could integrate within the car, as well as you know, do different parts of IoT, which is connecting to a more broader spectrum of other devices, not just have them in three different applications, but distribute them among others. But all in all, it was a very good prototype that we were able to apply. And it showed us functionalities that in future iterations we could go ahead and improve upon. So it was a rather gratifying experience, and I'm glad that I was able to implement my skills correctly. And that was basically it. Thank you.